everyone, it's Mr. Swank, and I am here with another lesson for you. Today is Wednesday, April 29th, and we are moving on from our talk of the metric system and measurements to something, well, it's still the same kind of stuff. So let's get into it and start the day with a joke, because it's how we start every day in Mr. Swank's class. Today's joke of the day. Helium walks into a restaurant. The waiter says, "We don't serve noble gases." Helium doesn't react. It's a chemistry joke. We don't get those as often because chemistry is serious business. No, that's not true. We can make a lot of jokes about it, but let's move on and look at today's objective. So today's objective is we're going to define and talk about how we measure density. So we are talking about, of course, density. We talked about our metric units beforehand, things like length, mass, volume, all of that, qualitative and quantitative measurements. We're still moving on from quantitative, talking about, numerical measurements of things. So what is density? Density is the ratio of mass to volume of an object. That means it is the mass, how much matter is contained in an object, per the amount of space it occupies, volume. Okay? It is a ratio of those two things. That means it doesn't get its own unique unit. The unit of measure for density is grams per milliliter. Gram, a unit of mass, per a unit of volume, milliliter. That shows that it's a ratio of mass to volume. Now, how does that work? Well, I'll give you an example here. For example, if you had 1 gram of water and measured its volume, it would be 1 milliliter. And of course, vice versa. If you got a milliliter of water, measured its mass, it would be 1 gram. Now, it's the ratio of mass to volume for density. So it's 1 gram per 1 milliliter, 1 to 1. What does that equal? That equals 1. That means the density of water is 1 gram per milliliter. Now, an important thing here is water is kind of a standard when it comes to density. We measure a lot of other things density-wise compared to water. And also, water is plentiful, and it gets used a lot in various sciences and, of course, in daily life. I mean, we need it for anything, so it's important. Now, something to consider with density is unlike mass, which, of course, can change because it says 1 gram of water in the example. Maybe we have 2 grams. Maybe we have 3 grams. Maybe we have 100 grams. Is that going to change the density? No, and that's because think about it. If you had 100 grams of water, do you think it would still just be 1 milliliter? Is it still just going to take up 1 milliliter of space? No, it's going to take up more space. Well, how much more? 100 grams of water would take up 100 milliliters of space. Now think about that in terms of density. 100 over 100. What's 100 over 100? 1. That means that water, no matter how much there is still a density of 1. Does that work for everything? Yes. Density is a physical property of a substance, and it is constant. We actually talked about that a little bit back in chapter 2 when we talked about physical properties. So, water will always have a density of 1, and that's important to know. Same with any substance. Its density is constant. We'll talk about that a little bit more going forward. The formula for density is mass over volume. We kind of just did that a little bit. Or abbreviated D equals M over V. That's how you find the density of anything. You take its mass divided by its volume, and that gives you the density. Simple enough. Now, I said a little bit that we compare water when it comes to density to a lot of other things to kind of get their densities. So let's talk about a couple of examples here. What happens to wood and water? So think about it. If you took a log and you threw it into a swimming pool or a lake or some other body of water, what would that log do in the water? And I mean in terms of floating or sinking. Would the wood float or would it sink? Hopefully you said it would float. Okay, so if the wood floats in water, what do you think that means in terms of the density? Remember, it's talking about density. How much stuff is packed into how much space? Do you think wood is more or less dense than water if it floats? Well, wood is on average about 0.5 grams per milliliter. That is less dense than water, which was a density of 1 gram per milliliter. And that is why it floats. If something floats in something else, that means the object that's floating is less dense than the thing it's floating in. So in this case, wood is less dense than water. Let's look at another one. What happens to lead in water? Well, think about it. If you took a chunk of lead, or really any metal, and you put it into water, what's going to happen to it? Is it going to float, or is it going to sink? Hopefully you said it would sink. Now, if it's going to sink, what do you think that means in terms of the density? Do you think that metal, or in this case specifically lead, do you think it is more or less dense than water? Hopefully you said more, because lead is 11.4 grams per milliliter. Lead is over 10 times more dense than water is, and that's why lead sinks. That's also why we say something like, it works like a lead balloon, because, lead's really dense. It's not going to float really well. By the way, if you want to try a real-world example of comparing densities, get a big container of water and get 2 cans of soda. One regular version, one diet version of the same thing. For example, get a Pepsi and a Diet Pepsi. Get a Coke and a Diet Coke. Anything if you can. Put them both in the container of water and see what happens. Keep in mind that the regular and the diet version are different. See what happens and see what you can tell me. If you can't do it on your own, don't worry. I'll talk about it tomorrow during the new video, and I will show you what happens. But if you get the chance, give it a shot. Anyway, guys, that covers our basics on density. So, of course, we talked about how to measure it. We talked about what it is. We talked about comparing densities, all that stuff. There's an assignment posted. Make sure you answer all the questions for that. And hey, for Mr. Swank's Chem 1 class, I'm Mr. Swank. And I'll catch you guys tomorrow.